Hey logicians, this is video 2 about Venn diagrams and predicate validity. And so if you're got the slides up at home, the main slideshow for this is number 14 titled Venn Diagrams. So just want to remind you again what the procedure is here when we're trying to test arguments for validity using Venn diagrams. We first, and this is on page 11 of the slides, number 14, we first diagram the premises of the argument being true, and then we see if we can diagram the conclusion being false. And if we can complete that diagram, that means there's a way that the premises could be true and the conclusion could be false, so we know that the argument's invalid. If we can't complete that diagram, we know that the argument must be valid because there's no way for the premises to be true and the conclusion to be false. And so in this video, what I want to do is go through 3 example problems. We've already done some in person in class, but this will give you just a little bit more practice, a little more chance to see it. So let me first write down the first argument. It's going to be the following here. Try to get this so you can see it. Premise 1, no A is B. Premise 2, sum B is C. And the conclusion, no A is C. Now before I even get started, what I like to do, just to remind myself, I'm not actually trying to diagram this, and this all being true. I'm trying to diagram this being true, and this being false. So what I'm going to do is I'm actually going to write down the negation of the conclusion first, so that I know that I'm trying to diagram the truth of the negation, that is, the conclusion being false. So you could look at your handout about Venn diagrams that have the negations on the corners, and you could figure out that no A is C. The negation of that is, and I'm going to write it in a different color, the negation is sum A is C. So really what I'm trying to do here, I'm going to try to diagram those 3 formulas being true, because again, if these are all true, then it means it's a case where the premises are true and the conclusion is false. So that's what I'm going to try to diagram. And if I can complete the diagram again, the argument is invalid. And if I cannot complete the diagram, the argument's valid. So let's see how this goes. First, we're going to draw our 3 circles for A, B, and C. So A, B, and C. And I'll label these just to keep us clear here. But first, let's start with the first premise. What's the diagram look like if no A is B? Well, if no A is B, there's no overlap between A and B. There's nothing in between the two. And so we're going to shade off this whole region here. And notice it goes all the way down through the C region there, because if no A is B, there's nothing in that entire overlap there. So that's premise 1 diagrammed. What about sum B is C? Well, if sum B is C, there's got to be something in the overlap between those 2 circles. But we already know there's nothing in this part of the overlap because we've already shaded it out. So we know that there has to be something in there. That's the only way there could be something that's both B and C, and so we're going to put an asterisk right there. And that represents the truth of the second premise. Move over here so it's easier to see. Finally, we have to see if we can diagram the falsity of the conclusion, that is, the truth of its negation. That is, can we diagram sum A is C? Can we do that? Well, if sum A is C, that means there has to be something in the overlap between A and C here. And although nothing can go there because that's got to be empty, we see there is a region here where something could go. We could diagram, and I'll use the orange again to sort of correspond to the fact that it's the negation of the conclusion. We can diagram that. We can complete our diagram. And since we can complete our diagram, we know that the argument must be invalid, because we've diagrammed the premises being true and the conclusion being false, by the negation of the conclusion being true. So that's our first example problem. Let's try one that's very closely related to this. We're just going to clear off the diagram here. one that's closely related to this, but that goes a different way. So we're going to have the same premises, no A is B, sum B is C, but our conclusion is going to be sum C, let me find my chalk, sum C is not A. So we have the same first two premises, but a different conclusion. And again, our first step always is to write down the negation of the conclusion. So what's the negation of sum C is not A? Well, if that's false, if it's not the case that sum C is not A, then all C's are A. And you can see that by looking at your handout if you'd like to, with looking at the negations on the corners, right? So again, we're going to see if we can make the premise is true and the negation of the conclusion true. That is the conclusion false. So let's go ahead and do it. The first two should be easy because just like the last one, no A is B is to shade this region. There's no overlap. There's nothing in the overlap between A and B. So that middle region gets shaded off. The next premise, sum B is C, that's just as before too. If sum B is C, there's got to be something in this sort of football-shaped region between B and C. It can't be there, but there is room there, so we can put an asterisk right there. And now we ask ourselves, can we diagram the truth of the negated conclusion? That is, can we diagram all C are A? Well, if all C are A, then there's nothing outside of C. Sorry, there's nothing inside of C that's outside of A. That is, there can't be anything in this whole moon-shaped region for C here. That is, we'd have to shade out all of this region here. But notice, we can't do that. We can't consistently shade out this region, this whole region, while also having something in that region, because the shading means there's nothing in there. It means it's unoccupied. So we can't complete the diagram. This diagram says that this region is unoccupied and occupied. That can't happen. So we can't get this. We can't draw a diagram of that, which means that there's no way to make the premises true and the conclusion false, which means the argument must be valid. Okay, I'm going to put one more example up here before we end this video. Give me a second to write it down. So the argument is, premise 1, sum A is not B. Premise 2, no B is C. And the conclusion, sum A is C. Okay, so once again, our first step is to write down the negation of the conclusion. The negation of sum A is C is what? Well, if it's not the case that sum A is C, there must be no A's that are C. So that's the negation. And again, we want to see if we can diagram these being true and the negated conclusion being true. We want to know if that's possible. So again, we're going to go over here and draw our diagram. We've got A, B, and we've got C. And diagramming the first premise here is going to bring out something we haven't seen yet, at least not on the video, although we did see it in class. So sum A is not B. How do we diagram that? We've got to draw an asterisk in the region of A that's outside of B. The region of A that's outside of B is this region here. I'm going to grab a blue piece of chalk here to show you the region. That's the region of A that's outside of B. That doesn't show up very well in the video. Hopefully you can see it okay. So we need to draw an asterisk there, but there's a question, notice. Do we draw it on this side of the line or this side? Because this whole region is sum A that's not B. So which side do we draw it on? And the answer is that if we're not forced to make a choice here, we want to draw it on the line. And let me explain what that means. When we draw the asterisk on the line, we say, look, we know there's got to be something in this sort of moon-shaped region, but we haven't yet had to decide which side of the line it can be on. So if later diagramming forces us to put it on one side or the other, we can move it if we need to. That's what the putting an asterisk on the line corresponds to. Okay, so that's the truth of the first premise. What about the truth of the second premise? No B is C. Well, we know how to diagram that. To say no B is C is to shade out the overlap between B and C, which is this region here. Okay, so we've got that done too. Now finally we want to try to diagram no A is C. How would we diagram that? No A is C. Well, we have to shade off the region of overlap between A and C. Can we do that? That's this region here. So whether or not we can do that really depends on which side of the line this asterisk is on. Is it up here or is it down here? If it were down here, we couldn't shade that off because then we'd have an occupied and unoccupied region. But remember, when it's on the line, it means we're free to move it either way if we need to, and so that's what we're going to do. We're going to say, we're going to move that asterisk up here. If there's something up there, there's still an A that's not B. There's still some A that's not B. And now we've been able to complete our diagram. And since we've been able to complete our diagram, it means that we have true premises and a false conclusion, and it means that this argument here is invalid. All right, that's it.